For problem number 4, when you want to combine circuits, this one's a little bit trickier to see, but if you look at the junctions, for example, I'm coming out of the positive and I see a junction at this point, these two resistors are in parallel. The reason why I know that is because they come back together in this junction here and split up into another set of parallel. So when I redraw this, it's easier to see what's happening when you draw it as two parallel circuits in series with each other. So this is basically what's going on here. I just drew it a little bit differently so that you can see the junctions clearly. So this makes it obvious which ones we need to combine. And I'm gonna do that by combining the two sets in parallel and turning this into a series circuit. So for this one, I've got 1 over 1200 plus 1 over 1400. This is gonna take a while. I end up with 646 because I took that whole answer and divided it by 1. And then I'm going to do the same thing with the 1600 and the 1800. And I'm going to take that answer and divide it by 1. And that I got as 847 ohms. And I add these two in series. And I get 100, about 150. It looks like they're rounding out by the hundredths. And so I'm going to round this up to 1500. From there, you can see that the next step is to solve for the total current. So that's going to be 0.008. And then that current, if I analyze what's happening, actually I can't, because the current that's coming out as 0.008 is splitting up at this junction. So unfortunately, I cannot transfer that current onto any of the other values. I also can't transfer the voltage because the voltage actually will divide between the two resistors. But what I can see is that if I have 646 ohms and 647 ohms in total, and I know those are my equivalent resistance, they will absorb 12 or dissipate 12 volts. So in that case, I am going to solve this problem by analyzing my simplified circuit. I know here that I have a current of 0.008 amps that comes out of the battery, which is the same current that goes through this combined resistor here and this combined resistor. And even though those resistors are in parallel, I can solve for the voltage in this simplified circuit here, and it will be able to transfer into my parallel circuits. So what I'm going to do is I'm going to take the fact that voltage is current times resistance. So I am going to multiply my current times my equivalent resistance of this combination resistor and I'm going to multiply those together, and I get about 5 volts. So this is about 5 volts. With that said, I should get something that resembles 7, because I know 5 plus 7 equals 12 for the 847. But let's actually do the calculation. I've got the same current going through this combined resistor here, this equivalent resistance. So I hopefully get something close to 7. I know there's going to be some rounding error, but I get about 6.7. So that's about 7. I'm going to round it up to 7, and that adds up to 12. So what we know is that because these circuits, the 1200 and the 1400, are in parallel, they are going to have the same voltage. They are separate wires or separate loops, and so both of them are going to get the full 5 volts, because when it goes through these separate loops here, then it should total the 12 volts. So I am going to write 5 volts under 12 and 1400, 7 volts under 16 and 1800, and then from there, or sorry, I wrote all of these in the wrong spot. And then from there, I can solve for the current. This is gonna take me a minute. So divide my resistance by the voltage. I get about, and I'm just gonna make sure that my answers line up here. 1, 2, 0.042. This one is going to be, oh, hold on, I missed a 0. I should have 0.0042. And then this one is going to give me 0.0036. Then I get 0.0044 and 0.0049. Yep, that looks, or sorry, 39. So that looks pretty close to what we have in the answer key. It's not perfect because there's some rounding error, but that's how you do problem number 4.